Hello my lovely students, you're welcome to a new lesson. Today I shall be teaching you statistics and we shall be looking at grouped data. From definition, statistics deals with the collection, presentation, studying, organizing, analyzing, and interpretation of information, usually numerical information or data. Also from definition, group data involves a large number of values which are organized or grouped into classes called class intervals. Let's learn more about statistics involving grouped data. From the information displayed here, group data involves the following. Number 1, class intervals. Number 2, class limits. Number 3, class boundaries. Number 4, class width. And number 5, class mid value. Number 1, class intervals. Class intervals clearly defines the various groups which the large number of values or data are grouped into. For example, from 1 to 5, 6 to 10, 11 to 15, and so on. These are various class intervals. Number 2, class limits. Class limits are the n numbers or values of each class intervals. That is, the lower class limit and the upper class limit. In a class interval of from 6 to 10, the lower class limit is 6, while the upper class limit is 10. Number 3, class boundaries. Class boundaries are the theoretical boundaries of each class interval. That is, the lower class boundary and the upper class boundary. In a class interval of from 21 to 30, the lower class boundary is the lower class limit minus 0.5, which is 21 minus 0.5. The lower class boundary is 20.5. While the upper class boundary is the upper class limit plus 0.5, which will give us 30 plus 0.5. The upper class boundary is 30.5. Hence, for a class interval of from 21 to 30, the class boundaries are from 20.5 to 30.5. Number 4, class width. The class width is the difference between the lower and upper class boundaries of a class interval. That means the class width is the upper class boundary minus the lower class boundary. For a class interval of 11 to 15, with class boundaries of 10.5 to 15.5, the class width is 15.5 minus 10.5, which is equal to 5. That means that in the class interval of 11 to 15, we have 5 numbers in that class representing the class width. The 5 numbers are 11, 12, 13, 14, and 15. Number 5, class mid value. The class mid value or class mark or class center is the midpoint of the class interval. We have two formulas to finding the class mid value. The first formula, the class mid value is equal to the lower class limit plus the upper class limit divided by 2. While the second formula for the class mid value is the lower class boundary plus the upper class boundary divided by 2. For a class interval of 6 to 10 with class boundaries of 5.5 to 10.5, the class mid value is the lower class limit plus the upper class limit divided by 2, which will give us 6 plus 10 divided by 2, which is 16 divided by 2, which is 8. Or the class mid value can as well be the lower class boundary plus the upper class boundary divided by 2, which is 5.5 plus 10.5 divided by 2, which will give us 16 divided by 2 again. The class mid value remains 8. Presentation of grouped data. Group data can be presented in the following ways. Number 1, grouped frequency distribution or frequency distribution table. Number 2, histogram. Number 3, frequency polygon. Number 1, grouped frequency distribution. This is a frequency distribution table in which large data is grouped into class intervals. Here's an example of a grouped frequency distribution having class interval and frequency. Number 2, histogram. This is a block graph that represents a frequency distribution. A histogram consists of rectangular bars with no gaps. The areas of the block or rectangles represent the frequency distribution. The horizontal width of each rectangle corresponds to the class width. For a histogram with class intervals of equal widths, the heights of the rectangles are proportional to the frequencies of the distribution. When drawing a histogram, the frequencies are on the vertical axis and the class boundaries are on the horizontal axis. Here's an example of how a histogram looks like, with rectangular bars with no gaps, having frequency on the vertical axis and class boundaries on the horizontal axis. Number 3, frequency polygon. In a frequency polygon, the frequencies are plotted at the midpoints or the class mid-values of each class interval. The points are joined by straight lines. The two endpoints are usually joined to the midpoints of the adjacent imaginary class intervals on the horizontal axis to form a complete polygon. When drawing a frequency polygon, the frequencies are marked on the vertical axis and the class boundaries are marked on the horizontal axis, just like in histogram. Here is an example of how a frequency polygon looks like. Moving on, let's see our first example on statistics, talking about grouped data. Example 1. The masses of 40 students in kilogram are recorded as shown below. We have various numbers here. We have 60, 64, 63, 67, 66, 68, 59, 58, 59, 60, 64, 66, and so on. Construct a group frequency distribution of the data, taking equal class intervals of 56 to 60, 61 to 65, and so on. Let's see the solution to example 1. From the tally sheet involving class interval, tally, and frequency, the first class interval is from 56 to 60, talking about 5 numbers in that class. The second class interval is from 61 to 65. The next class interval is going to be from 56 to 70, while the last class interval is from 71 to 75. Because this class from 71 to 75 contains the biggest number in the question, which is 73. So counting the numbers in the question, we have 8 numbers in the class from 56 to 60. So the frequency for that class is 8. We have 16 numbers in the class of from 61 to 65. So the frequency for that class is 16. We have 12 numbers in the class of from 66 to 70. So the frequency for that class is 12. While we have 4 numbers in the class from 71 to 75. So the frequency for that class is 4. Totaling your frequency, the sum of the frequency should be 40 because the question involves the masses of 40 students. Here is the group frequency distribution, having the class intervals at the top row while the corresponding frequencies at the bottom row. I hope this solution is clear to you. Let's look at example 2. Question A. Draw a Roman figure 1 histogram and Roman figure 2 frequency polygon for the frequency distribution given below. We have the class interval of from 0 to 4 having a frequency of 4, the class of from 5 to 9 having a frequency of 6, the class of from 10 to 14 having a frequency of 8, the class of from 15 to 19 having the frequency of 7, and the class of 20 to 24 having a frequency of 5. Question B. Calculate the mean of the distribution. In the histogram, we are plotting a graph with the frequency on the vertical axis and the class boundaries on the horizontal axis. We are plotting rectangles or bars with no gaps. So for the first class boundaries of -0.5 to 4.5, we plot that rectangle against the frequency of 4. For the second class boundaries of 4.5 to 9.5, we plot that class boundary against the frequency of 6, and so on. Let's see solution to question 2a, Roman figure 2, talking about drawing a frequency polygon. Now, to draw a frequency polygon, we are going to need the class mid values. Don't forget, to determine the class mid values, it's either you add the lower class limit to the upper class limit divided by 2, or the lower class boundary plus the upper class boundary divided by 2. So for the first class interval of 0 to 4, the class mid value is going to be 0 plus 4 divided by 2, which is 4 divided by 2, which will give us 2 as the class mid value. For the second class interval of from 5 to 9, the class mid value is going to be 5 plus 9 divided by 2, which will give us 14 divided by 2, which will give us 7, and so on. Now that we know our class mid values, this is how the frequency polygon will look like. This is the frequency polygon having the frequency on the vertical axis and the class mid values on the horizontal axis. We are plotting the class mid values against the frequency. So for the first class, we are plotting 2 against the frequency 4. For the second class, we are plotting 7 against the frequency 6, and so on. Don't forget to close up your frequency polygon. We are going to draw the first and the last class mid values to the imaginary class mid values to the left and to the right, which will give us -3 to the left and 27 to the right to close up your frequency polygon. Don't forget, a polygon should be a closed shape with straight sides. For solution to question 2b, to calculate the mean of the distribution, the formula for mean is sum of fx divided by sum of f. In this question, we are given the frequencies, so the sum of the frequency is 30. While we are going to use the class mid values as our x. So to get our value for fx, we are going to multiply our frequency values and the corresponding class mid values for each class. So for the first class, the value of fx is 4 times 2, which is 8. For the second class, the value of fx is 6 times 7, which is 42, and so on. Totaling your values for fx, the sum of fx will give us 375. When you substitute these values into your formula for mean, what will be the mean of the distribution? Let's see if you are right. Since the mean is sum of fx divided by sum of f, the mean becomes 375 divided by 30, which is equal to 12.5. I hope the solution to question 2 they are clear to you. Please note that the mean can also be found by choosing a working or assumed mean and finding the deviations from it. Let's see the solution to question 2a, Roman figure 1, talking about drawing a histogram. Now to draw a histogram, we're going to plot the frequency on the vertical axis and the class boundaries on the horizontal axis. From the question, the class interval and the frequency are stated. What we need to find are the class boundaries. Don't forget, the lower class boundary is gotten from the lower class limit -0.5, while the upper class boundary is gotten from the upper class limit plus 0.5. If you do this, for the first class interval of 0 to 4, the lower class boundary is going to be 0 minus 0.5, which will give us minus 0.5. While the upper class boundary is going to be 4 plus 0.5, which will give us 4.5. In the second class interval of from 5 to 9, the lower class boundary is going to be 5 minus 0.5, which will give us 4.5. While the upper class boundary is going to be 9 plus 0.5, which will give us 9.5, and so on. When we complete the class boundaries, here is how the histogram will look like. That means another formula for the mean is the assumed mean plus sum of the frequency times the deviation from the mean divided by sum of frequency, which is equal to the assumed mean plus sum of frequency times the x value, which are the class mean values, minus the assumed mean divided by sum of frequency. In this formula, A represents the working or assumed mean, while D represents the deviation from the mean. Please take note of this formula for working or assumed mean. Looking at example 3, the table below shows the marks obtained by 40 students in a mathematics test. The table involving marks and number of students. Question A. Draw a histogram for the mark distribution. Question B. What is the modal class? Question C. Use your histogram to estimate the mode. Question D. Calculate the median of the distribution. Let's see the solution to question 3A, talking about drawing a histogram for the mark distribution. From the table here, the marks involves the class intervals, while the number of students represents the frequency. Don't forget, to know the class boundaries, we are going to subtract 0.5 from the lower class limits and add 0.5 to the upper class limits. The results are shown in the table displayed here. Plotting the frequency on the vertical axis against the class boundaries on the horizontal axis, this is how the histogram should look like. Here is the histogram for the mark distribution. For the solution to question 3B, the modal class should be the class with the highest or greatest frequency. So looking at our histogram, which class do you think is the modal class, having the greatest or the highest frequency? In other words, the class with the tallest rectangle. Let's see if you are right. From the table and histogram, the modal class is 30 to 39. I hope you got that right. For the solution to question 3C, using the histogram to estimate the mode. The mode is obtained from the histogram by drawing lines joining the upper vertices of the rectangle for the modal class with the vertices of the adjacent rectangles. The mode is read at the point where the lines cross. This is shown in the histogram displayed here. From the histogram, the mode is equal to 35.5. Looking at a solution for question 3D, talking about calculating the median of the distribution, here is the formula for the median of the distribution. The median is equal to L plus, in brackets, N divided by 2 minus sum of FL, in brackets, times C divided by F median. Here, L represents the lower class boundary of the median class, N represents the total frequency, Sigma FL or sum of FL represents the sum of the frequencies of the class intervals lower than the median class. F median represents the frequency of the median class, while C represents the class width of the median class. Please take note of this formula for the median of a grouped frequency distribution. From the question, the median class is n plus 1 divided by 2 Mach, which is 40 plus 1 divided by 2, which is 41 divided by 2, which is the 20.5 Mach. When you count the 20.5 Mach in our grouped frequency distribution table, the median class is from 30 to 39. That means L is equal to 29.5, N is equal to 40, sum of FL is 4 plus 5 plus 6, which is 15, F median is 12, while C is equal to 39.5 minus 29.5, which is equal to 10. When you substitute these values into your formula for median and you calculate, what will be the median of the distribution? Let's see if you are right. When you substitute the values into the formula for median and you calculate, the median is equal to 33.67. I hope you got this answer correctly. Once again, please take note of all the solutions for example 3. Lastly, let's learn about cumulative frequency. This involved 6 of the terms listed here. Number 1 is cumulative frequency table. Number 2, cumulative frequency curve. Number 3, quartile. Number 4, interquartile range. Number 5, semi-interquartile range. And number 6, percentile. Number 1, cumulative frequency table. A cumulative frequency table shows progressive increase in total frequency. Here is an example of how a cumulative frequency table looks like. Here we have the class interval, the frequency, and the cumulative frequency. To obtain the cumulative frequency, we progressively add the frequencies. So for the first class, the cumulative frequency is 2. For the second class, the cumulative frequency is 5 plus 2, which is 7. For the third class, the cumulative frequency is 7 plus 7, which is 14. For the fourth class, the cumulative frequency is 9 plus 14, which is 23, and so on. Number 2, cumulative frequency curve. A cumulative frequency curve, or OGIF, is an S-shaped curve that shows cumulative frequency against corresponding data. When drawing a cumulative frequency curve, the cumulative frequencies on the vertical axis are plotted against the corresponding upper class boundaries on the horizontal axis of the class intervals. Here is an example of a cumulative frequency curve having cumulative frequency on the vertical axis and the upper class boundaries on the horizontal axis. Number 3, quartile. Quartile is 1/4 of the distribution. Quartiles divide data into 4 parts. There are 3 types of quartiles. Number 1 is the lower quartile Q1, which is 1/4 or 1/4 of n plus 1 term. Number 2 is the second quartile Q2, which is 1/2 or half of n plus 1 term. Please note that the second quartile is the median. While number 3, upper quartile Q3, is 3/4 or 3/4 of the n plus 1 term. Here, n is the total or cumulative frequency. Number 4, interquartile range. The interquartile range, QIR, is the difference between the upper quartile and the lower quartile. That means QIR is equal to Q3 minus Q1, representing the upper quartile, minus the lower quartile. Number 5. Semi-interquartile range. The semi-interquartile range, Q, is half of the interquartile range. That means that Q representing the semi-interquartile range is equal to Q3 minus Q1 divided by 2, which represents the upper quartile minus the lower quartile divided by 2, or half of the interquartile range, which is interquartile range divided by 2. Number 6. Percentile. Percentile is 100th of the distribution. Percentile divides data into 100 parts. Please note that the lower quartile Q1 is equal to 1 over 4 times 100 percentile. That means the lower quartile Q1 is equal to the 25th percentile, which is equal to 25% of n plus 1's item. Also, the second quartile Q2 is equal to 1 over 2 or half times 100 percentile. That means the second quartile Q2 is equal to the 50th percentile, which is equal to 50% of n plus 1 item, and this represents the median. Lastly, the upper quartile Q3 is equal to 3 over 4 or 3/4 times 100 percentile. That means the upper quartile Q3 is equal to the 75th percentile, which is equal to 75% of n plus 1's item. Here, n is the total or cumulative frequency. Please take note of all this information for group data involving cumulative frequency. Thank you very much for going through the lesson today. I want to advise that for you to get more information about the topic statistics involving group data, please continue to read your textbook. Don't forget to attempt your quiz and your assignment. I hope to see you again in our next class. Until then, it is goodbye for now. Thank you very much.